Welcome to Learner's Prep. In this session, we will solve some more problems based on the concept of LCM and HCF. This is the second session in this topic of LCM and HCF. Question number 16. What is the smallest 3-digit number which when divided by 4, 6, 8 and 9 leaves 3 as a remainder in each case? So here we have to find out the LCM of the four numbers 4, 6, 8 and 9. So let us find out the LCM for all these numbers 4, 6, 8 and 9. So here in these four numbers 8 is a multiple of 4. So you can cancel 4. So prime factorization of 6 is 2 into 3 and prime factorization of 8 in exponential form it is 2 cube, 9 is 3 square. So what is the LCM? LCM is the highest powers of all the numbers. So for 2 the highest power is 3 and for 3 highest power is 2. So that is 2 cube into 3 square. 2 cube is 8, 3 square is 9. So 8 into 9 which is 72. 72 is the LCM of all these four numbers. So we need to find out the smallest 3-digit number which is divisible by 72. So the smallest 3-digit number is 100. Smallest 3-digit number is 100. Now after 100, what is the number which is divisible by 72? So let us divide 100 by 72 and let us find out how much is falling short. So 72 once 72 that will be less than 100. So we should go for 72 twos. 72 twos is 144. So if you subtract you will get minus 44. So 44 is falling short. So if you add 44 to 100, 100 plus 44, you will get 144. So this 144 is the smallest 3-digit number which is divisible by 72. So that means when you divide 144 with 72, you will get a remainder of 0. So, but here in the question, we should get a remainder of 3. So to get remainder 3, we need to add 3 to 144. So if you add 3, you will get 147. So this is the smallest 3-digit number which leaves remainder 3. 147. Option D is the correct answer. Question number 17. Find the smallest number which when divided by 3, 4, 5 and 6 leaves a remainder 2 in each case, but when divided by 7 leaves no remainder. So here also we have to find out the LCM for all these four numbers. So for 3, 4, 5 and 6. Since 3 is a factor of 6, 3 can be cancelled. So for 4, prime factorization is 2 square. So 5 and 2 into 3. So what is the LCM here? LCM is the highest factor of 2 is 2 and we are left with 3 and 5. So that is 4 into 3 into 5. 4 3 is 12, 12 5 is 60. So the LCM is 60. So if you add 2, you will get a number which is divisible by all these four numbers and leaves remainder 2. 60 plus 2, 62. This leaves a remainder 2. So not only this number, any multiple of 60 plus 2 leaves a remainder 2. So 60 multiple is 120. Next multiple is 120 plus 2. So 122. This also leaves remainder 2 when you divide with any one of these 4 numbers. So out of these numbers 62 and 122 and so on, we have to find out the number which leaves no remainder when divided by 7. So the next multiple of 60 is 63's 180 plus 2 is 182. So now let us check which number is divisible by 7. 62 is not divisible by 7. 122, 7 ones and 52. 52 is not divisible. So 122 is not divisible. 182, 7 twos 14, 7 6 42. So 182 is divisible by 7. So that means 182 leaves remainder 2 when divided by any one of these 4 numbers, and also leaves 0 remainder when divided by 7. So our answer is 182. So option C is the correct answer. Question number 18. The smallest number which when diminished by 4 becomes divisible by 6, 8, 9 and 12 is. So we have to find out the LCM here for all these 4 numbers. The smallest number which when diminished by 4 becomes divisible by 6, 8, 9 and 12. 6, 8, 9 and 12. So among these 4 numbers, 6 is a factor of 12. So you can eliminate 6. So find the prime factorizations. 2 cube, 3 square, 4 into 3. So the LCM of all these numbers is the highest powers 2 cube into 3 square. That is 8 into 9, which is equals to 72. 72 leaves remainder 0. So here we need to find out the smallest number which when diminished by 4. So that means 72 plus 4 we will get 76. 72 plus 4 we will get 76. So 76 when diminished by 4 we will get 72. So that's why we should add 4 here. So when 76 is diminished by 4, it will be divisible by all the 4 numbers. So answer is 76. Option C is the correct answer. Question number 19. The smallest number which when increased by 5 becomes divisible by 8, 10, 12 and 15. So here also we have to find out LCM for all these 4 numbers 8, 10, 12 and 15. So there are no factors and multiples here. So directly find out the LCM. 8 is 2 cube, 10 is 2 into 5, 12 is 4 into 3 and 15 is 3 into 5. So what are the highest powers? For 2, highest power is 3, and for 3 it is only 1, and for 5 it is only 1. So that is 8 into 3 into 5. 24 into 5 is 120. The LCM is 120. Now, so 120. So we should find out a number which is by adding 5 we should get 120. So that means we have to subtract 5 from 120. So from 120, if you subtract 5, we will get 115. So for 115, when you add 5, we will get 120, which is divisible by all these 4 numbers. So 115 is our answer. So that is when increased by 5, that number whichever we get will be divisible by all the 4 numbers. So option A is the correct answer. Question number 20. What will be the smallest number which when tripled becomes exactly divisible by 8, 12, 15 and 20? So here also we need to find out the LCM. So here we can also use options, but that will take time. So we will directly find out the LCM. So finding the LCM is a shortest method. 8, 12, 15 and 20. This is 2 cube. This is 2 square into 3. This is 3 into 5. This is 4 into 5. So the LCM is the highest powers 2, highest power 3, 3 is highest power 1, 5 highest power is 1. So that is 8 into 3 into 5. So 8 3 is 24, 24 5 is 120. Now we should find out a number from options which is when tripled it should become 120. So it is obvious. So that means 120 you can divide with 3. So what do we get? 40. So 40 when tripled we will get 120. So if you divide 120 by 3, we will get a number which when tripled it becomes 120. So our answer is 40. So 40 when tripled it becomes 120, which is divisible by all these 4 numbers. So answer is option B is the correct answer. Question number 21. What is the least number that should be added to 125 so that the resulting sum is exactly divisible by 3, 4 and 6? So LCM for 3, 4 and 6. 3, 4 and 6. So for 3 we can eliminate it because 3 is a factor of 6. So the LCM is 2 square into 3, which is 12. 4 into 3, 12. Now the least number that should be added to 125. That means the next number after 125 which is divisible by 12. So we have to divide and find out how much is falling short. 125 divided with 12. So we'll get 12 tenths 120, which is less than 125. So we should find out the next number after 125. So we should take 12 11ths. So 12 11ths 132. 12 11ths 132. So if you subtract, how much you will get? Minus 7. So that means 7 should be added to 125. Then it becomes 132. Then it will be divisible by 12. So 125 plus 7 is 132. So how much we need to add here? We need to add 7. So we have to add 7. So that is our answer. C is the correct answer. Question number 22. The sum of two numbers is 80. Their difference is 1/4 of their sum. Find the LCM of the two numbers. The sum of two numbers is 80. X plus y is equals to, let the numbers be x and y. Let the numbers be x and y. So their sum is 80. x plus y is equals to 80. And their difference is 1/4 of their sum. So 1/4 of 80 is 20. So here we got two equations. We have to solve these two equations by adding. So if you add the two equations, plus y minus y gets cancelled. So we are remaining with 2x. X plus x is 2x. 80 plus 20 is 100. So that gives us x is equal to 100 by 2, 50. So if you substitute x value 50 in the first equation, 50 plus y is equal to 80. Y is equal to 80 minus 50, 30. So what are the numbers here? 50 and 30. 50 and 30 are the two numbers. So we need to find out their LCM. So their LCM is 2 25 times. 25 is 5 square. This is 2 15s. 15 is 3 into 5. So what is the LCM? 2 highest power is 1, 3 highest power is 1, and 5 highest power is 2. So that is 25. 25 threes 75. 25 threes 75. 75 twos 150. So the LCM is 150 for the two numbers. Option D is the correct answer. Question number 23. What is the least number from which 8 must be subtracted so that the result is exactly divisible by 12, 18 and 20? So we have to find out the LCM for both the three numbers. So what are the three numbers here? 12, 18 and 20. So for 12, prime factorization is 4 threes. This is 9 twos and this is 4 fives. So the LCM is the highest powers 2 square, 3 square and 5. 4 into 9 into 5. So that is 5 fours 20. 20 into 9 180. So the LCM is 180. So what is the least number from which 8 must be subtracted? So if you subtract 8, we should get 180. So that means we should add 8 to 180. 180 plus 8 is 180. So this is the least number from which if you subtract 8, it will be divisible by all these three numbers. Option B is the correct answer. Question number 24. What is the least number which when divided by 8, 10 and 15 leaves the same remainder 2 in each case? So least number which when divided by 8, 10 and 15 leaves the same remainder 2 in each case. So here also we have to find the LCM for all these three numbers 8, 10, 15. 8 is 2 cube. This is 2 into 5. This is 3 into 5. The LCM is 2 cube into 3 into 5. 8 into 3 into 5. So 8 3 is 24. 24 5 is 120. So the question is, the remainder should be 2 in every case. So that means add 2 for 120. If you add 2, you will get a remainder 2 in every case. Every time whenever you divide with any one of these three numbers, you will get 2 as the remainder. Add 2. You will get 122. So 122 when divided by any one of these three numbers, we will get 2 as the remainder. Option C is the correct answer. Question number 25. Find the LCM of the following algebraic expressions. So here two algebraic expressions are given. So first of all, we have to factorize these algebraic expressions. So first expression, let us take 4x cube plus 20x square plus 24x. So first of all, let us take out the common terms in all these three terms. So 4 is divides all the coefficients. So you can take 4 common, and also x square is common in x is common in all these three terms. You can take x also common. So what is remaining here? In 4x cube, 4 is taken common, x is taken common, x square remains, and 20 is divisible 5 times, and from x square, x is taken common, 1x remains, and 24 is divisible 6 times, and 1x is taken common. Now we can also take factorize this quadratic trinomial, x square plus 5x plus 6. So this can be written as x plus or minus something and x plus or minus something. We should write two numbers beside x such that their sum is a coefficient of middle term and product is the constant term 6. So if you choose such numbers, we will get here 3 and 2, plus 3 and plus 2. Their sum is plus 5 and product is plus 6. So the factors of x square plus 5x plus 6 are x plus 3 and x plus 2. So these are the three factors. So similarly, next expression is 2x power 4 plus 6x cube minus 8x square. So here all the three coefficients are divisible by 2. 2 is common, and also x square is common. So in the first term, x square remains, 6 is divisible 3 times and 1x remains, 8 is divisible 4 times, x square is taken common, only 4 remains here. Similarly, if you factorize this quadratic trinomial, so if you write the numbers such that the sum is the coefficient of middle term and the product is a constant term. So if you choose such numbers, you will get here plus 4 minus 1. So sum is 3, product is minus 4. So these are the factors of both the expressions. Now let us find out their LCM. So LCM, if you consider, so in both for 2 and 4, the LCM is 4 because 2 is a factor of 4, and for x square is common in both. So write down x square, x highest power is 2, so that is written x square as it is, and we have x minus 1, x plus 4, x plus 3, x plus 2. So all the factors are only one time. So write down as it is, x plus 4, x minus 1, x plus 3, x plus 2. So this is the LCM of the expressions. So Let us verify the options here. 4x square is in A, C and D. We have x minus 2 in A, so A cannot be. Next, C, if you check, we have x plus 2, x plus 3, x minus 1, x plus 4. C is having all the terms, and if you check D, we have x plus 2 whole square. So x plus 2 whole square is not correct. So C is the correct answer. C is the correct answer. Question number 26. Find the LCM of the fractions. So whenever we have fractions, so LCM of fractions is, so LCM of fractions. So the formula is LCM of fractions is LCM of numerators, LCM of numerators divided by HCF of the denominators. This is the formula, HCF of denominators. So we should use this formula here to find out the LCM of the fractions. So what are the numerators here? 2, 3, 4 and 7. 2, 3, 4 and 7. So 2 is a factor of 4, eliminate it. So 3, 4 and 7, they are all only ones. So you should directly multiply. So what is the LCM here? 2 square into 3 into 7. 4 3 is 12, 12 7 is 84. So the numerator is 84. And for HCF, let us use a division method. So it is obvious here, all the 4 numbers 5, 10, 15 and 20. The highest factor is 5 for all these numbers. So you can directly write here 84 is the LCM of numerators and HCF of the denominators is 5. So all the numbers are divisible by the 5. That is the highest number. So option A is the correct answer. Question number 27. 3 numbers are pairwise co-prime. The product of the first 2 numbers is 35 and the product of the last 2 numbers is 77. What is the sum of the 3 numbers? So let us assume the 3 numbers be x, y and z. So let the numbers be x, y and z. The product of first 2 x and y is 35 and the product of the last 2 y into z is 77. What is the sum of the 3 numbers? Now for xy and yz, so this is xy, this is yz. So for xy and yz, the HCF is y. HCF is y. For xy and yz, the common is y. So that is the HCF. HCF is y. And for 35 and 77, what is the HCF? Let us find out. 35 and 77. So both of them are divisible by 7. 7 5s, 7 11s. That's all. 5 and 11 are co-prime. They are not divisible by any number. So 7 is a HCF. So y is equal to 7. So for variables x, y and yz, HCF is y. So for values, it is 7 is a HCF. So he is asking what is the sum of the 3 numbers. So when xy is equal to 35, y is 7, x will be equal to 5. Y is equal to 7. Yz is equal to 77. Y is 7, then z will be 11. Z is 11. So sum of all these numbers, x plus y plus z, 5 plus 7 plus 11. So that is equals to 5 plus 7, 12, 12 plus 11, 23. The answer is 23. Sum of the numbers, 23. Option C is the correct answer. Question number 28. 4 prime numbers are written in ascending order. The product of the first 3 numbers is 105 and the product of the last 3 numbers is 385. What is the fourth number? So let us assume the 4 numbers. So let the numbers be A, B and C. A, B, C and D. There are 4 numbers A, B, C and D. They are in the ascending order. Product of the first 3. Product of the first 3 A into B into C is 105. And the product of the last 3 B into C into D is 385. What is the fourth number? So A into B into C is ABC and B into C into D is BCD. This is asking us to find out the fourth number. So what is the HCF for ABC and BCD? Common. The common variables are B and C. So that will be the HCF. For variables, the HCF is BC. And now for values, what is the HCF? So let us check. So they are divisible by 5, 21 times, 5 sevens, 35, and then again 5 sevens, 35. So 21 and 77, they are divisible by 7, 7 threes, 7 11s. 3 and 11 are co-primes. So 5 and 7 are the divisors, common divisors. So that is a HCF, 5 into 7. So 5 into 7 is a HCF. So this is 5 into 7, that is a HCF. 35. HCF is 35. So we know the value of BC. We have to find out to D. So if you divide BCD with BC, you will get D. What is BCD? 385. What is BC? 35. So if you simplify, BC gets cancelled. 35 once, 35, 3 remains, again 35, 11. So what is remaining? 11. So therefore D is equals to 11. The fourth number is 11. So answer is option C. Question number 29. Find the HCF of the fractions. So same as LCM, HCF of the fractions also we have a formula. HCF of fractions is equal to HCF of the numerators, HCF of the numerators divided by LCM of the denominators, LCM of the denominators. So this is the formula to find out the HCF of the fractions. So the numerators are 3, 5 and 7. So all of them are co-primes. All the 3 are co-primes. So for co-primes, HCF is 1. HCF of co-primes. Co-primes is 1. For co-prime numbers, the common factors are only 1. So, their HCF is 1. So, LCM let us find out for 4, 6 and 9. 4 is 2 square. This is 2 into 3. This is 3 square. So, LCM is 2 square into 3 square. 4 into 9, 36. LCM is 36. HCF is 1. So, what is the fraction here? HCF here 1 by 36. So, this is the HCF of the fractions. 1 by 36. Answer is option A. Question number 30. What is the HCF of 1.8, 0.9, 0.45? So, here we have to find out the decimals. Decimals are given here. So, whenever you have decimals, we have to convert them into whole numbers. So, to convert decimals into whole numbers, we should multiply with multiples of 10. So, here there are maximum 2 decimal places. So, we should multiply all the 3 decimals with 100. Then decimal point will be eliminated. So, 1.8, if you multiply with 100, we should also divide with 100. Then it is balanced. So, it becomes 180 by 100. Similarly, 0.9 multiplied by 100 divided by 100. That becomes 90 by 100. 0.45 multiply with 100 divide with 100. You will get 45 by 100. So, now we have 3 fractions. So, what is a HCF? HCF is the previous question we have seen. HCF is HCF of the numerators 180, 90, 45. So, what is the HCF here? Divisible by 5. This is 5 3s, 5 6. This is 5 1s, 5 8s. This is 5 9s. So, now they are divisible by 3, 12 times, 6 times, 3 times. Again divisible by 3, 4 times, 2 times and 1 time. So, all the 3 numbers are divisible by only 5, 3 and 3. So, HCF is 5 into 3 into 3, which is equal to 15 into 3, 45. So, the numerator is 45 and denominator is LCM of the denominators. So, all the 3 denominators are 100. So, their LCM is also 100. So, 45 by 100 is nothing but 0.45. 0.45. So, that is a HCF of all the 3 decimal numbers. So, you have to convert them into fractions such that all the numerators are whole numbers and then find the HCF of those fractions. So, option B is the correct answer. So, these are the problems based on the concept of LCM and HCF. We will solve some more models of questions on this concept of LCM and HCF. So, we will meet in the next session. Thank you.